first of all, we need to talk about a few notes here. That's all I'm going to cover today. Just a few notes. We'll be done early, I know we will. But there's a couple problems that I want to cover today. That's in the basic section that I want to cover. So we're dealing with a lot of slope today. So the big thing today is I want to make sure that you understand what slope is and all that good stuff. Okay? So, all right. Okay, all right. First of all, let's talk about the basic problems here. So there's going to be one problem in particular that you're going to have in your homework eventually tomorrow. It'll ask you to place A, B's, and C's on the graph where certain slopes are at. Okay, so like for instance, they're going to give you different slopes like this, and they're going to ask you to place slopes. So let's say this is. So let's say the slope here, let's say this is the function, this is function x, and they'll say, okay, slope at that moment was half, slope at one moment is 2, slope at one moment is negative 1/5, and slope at one moment was 0. Okay? Slope at one moment was 0. Okay, and they have an A, B, C, and a D. They're going to ask you to go place those on the graph. So when you get to that problem in the homework eventually tomorrow, I will ask you that I want you to draw the rough drawing of it. It doesn't have to be on graph paper. Just draw roughly what the thing's doing, put the dots where you think they're kind of at, and then push the A, B, and C kind of where you think they should be. So like for instance, where would a spot on this graph be a slope of half?
That one.
Yeah.
Which one? Going left to right, which one? Second one, I agree with that. That's probably where A is at. The reason why, just estimating, it looks like that slope is like tilted, so it looks like it's rising 1, running 2. You want, what are you doing?
It's either.
Okay, you want to put him up here?
He's driving.
Oh, don't talk. Hang up and tell him to call me when he's back home. All right.
I'll just shut it, right?
Okay, all right. Okay, all right, next. B. Where would B be found?
1.
First one. I agree with that. B is right here. The reason why, it's the most steep slope that we have. It's definitely steeper than this one. This one looks like it's rising 1, running 2. This one's definitely going up and down further. Okay, what about the next one?
The third one.
Third one. Okay, I agree with that. It's going down, it's negative slope. And the last one obviously is this one, letter D. That makes sense. You're right at the top or valley, so it's got a slope of 0. Okay. I would back it up a little bit further in case that thing falls.
That's
all
all
right. That
right.
phone fall off. There you go.
I don't care.
Okay.
At this point.
Okay, does that make sense?
Yeah.
Also, here's the graph.
If that's it, I'm just hanging up the phone. I need a question.
We're not a
We're not.
All right. Okay. All right. Hey. All right. Hey. Anyway, do we understand the first kind of problem you're gonna have? Okay, that's going to be at one point in the assignment. It's not the first exact problem you're going to have. It'll be at some point. Now, second type of problem you're going to have. The second type. This one's a little more challenging. Okay, and it's based on just if you know what slope is, like a tangent line. A tangent's a slope of a certain curve. So let's say that this is your problem. Okay, and they're going to give you this dot right here, which is obviously 2, 1, and so off to the side, they say f of 2 is 1, and f prime of 2 is, let's say, 4/5. Okay? And they want to know, like that, they want to know B, the coordinate for B down the road. They want to know the coordinate for B. That's a tough problem. In fact, that's got a lot of parts to it. Just a concept. I want to explain how I would do this problem, just to show you what it would be. Once you see the way that I'm going to show you, it's a lot easier than what they expect you to do. Okay. So this coordinate for B. Well, the first thing I'm going to do is I need to figure out the x for that one. So that's 1, 2, 3, 4, 5. So this is 5 comma something. Right? Does that make sense what they want you to find?
Yes.
They want to find that coordinate. So I can do that because they gave me enough information that I can write an equation of a line with that. Okay, 2 comma 1, and they gave me the slope is 4 or 5. If I just use point slope form, I have the equation of the line. Point slope form is written like this. This is something we did last year in pre-calc. The book does not tell you to do this. This is the way I would do it, because it's easier. My slope is this thing right here. That's the slope. It's how I know that. This little prime symbol, it's a little apostrophe, that means slope. The slope at 2 is 4/5 at this current moment. I put in a 4/5. That's my slope. My coordinate that I'm plugging, this is my x, this is the y. How I know that? This is the functional value. When you plug in numbers into a function, it gives you y answers. So this would be 2, and this would be 1. Does that make sense now? That's point slope form. They gave me a point, they gave me slope. At that moment, 2. If that was a different number, then we have a problem. It's got to be 2 because that was the slope that they told me. Now, I can figure out what the y number is because do you agree that that point B is somewhere on the line?
Yeah.
And it's on the line, right? So if I just plug in 5 here, it'll spit out my y number I need. That's the whole point. So if I just plug in 5.
3.
So this is what I have here. This is 5. Okay, if I plug in 5, it will spit out the y number, and I agree with that. This turns out to be 3. And I'll just go through and figure out what that number is. So this turns out to be 12 over 5. If I multiply that, I'll have to add the 1 across. And this is technically the y number. This is technically the y number. I mean, you could stop there. That's the y number. That's the coordinate. Now, if you want to actually figure out what that number is,
3.4.
is it 3.4?
Yeah.
Okay. That would be 3.4 total. Makes sense. All right. Questions at all about how that worked?
So it doesn't matter if you're on the scale or not?
No, they're not going to be. So,
I was going to say, well, that's 6.5.
yeah. So, it's definitely not from the scale. I kind of wanted it. But that was one of the problems. They want you to just get used to like knowing what slope is, how to use it. They didn't remind you how to do linear equations. It's just something you should be able to do. Now, what you're actually looking at here, this line that is hitting this point at 2, this is called a tangent line. That's something that we are going to bring up in pre-calc a little bit. We never really did discuss that a lot. A tangent line is a moment where it just grazes a curve at
Oh, so
one
it's not
exact
actually touching.
location. What?
So it's not actually touching.
It's not, it's touching the line at exactly one moment, but it's not passing through. It's not like a secant where it hits the line twice. It's the perfect slope of the line at that moment. It's the perfect slope of the curve at that moment. It's the instantaneous slope. It's the derivative. It's the differential quotient at that moment. So it's probably the most accurate slope that you could have at that exact moment, is having the tangent line. And that's something we haven't seen yet. This is a new concept. We've never seen tangent lines. I like this type of problem. I think that's interesting that they can have you figure it out. Okay, so all right.
I thought you chose.
Okay, all right. Let's go through another one of these. I'm just going to pick a different one out of the textbook that I'm just going to use some numbers. Something that's really close to that, but I just want you to see a different one.
Wait, Caleb. Thank you.
I'll leave it up there just for a few seconds.
Thanks.
How's your day been going?
Oh, just PG.
You sound like a sarcastic, just PG.
No, it's good.
Is this a real word?
I guess I've never heard someone say just.
Don't gaslight me by telling me that.
Jared, don't question it.
Isaac doesn't have any questions. Long question.
I don't know.
Are you driving? He's still driving. Is that
Probably
the real
talking, we just don't know he's like.
No, he's
That man's-
driving.
That man's not going to survive isolation.
Isaac, can you hear us?
Of course.
Isaac, I'm calling it right now. You are not surviving isolation.
I'm gonna die. Is that what you're saying?
That's what I'm saying.
Haley.
All right, it's not funny to joke right now.
The way you are, you're too social. You're not going to be able to handle it.
He's just gonna work.
I'm too what?
Too
Okay.
social.
All right. Hey,
Yeah, I don't know, dude.
I'm gonna mute it.
I don't know.
All right.
That's fine.
Okay. All right. So here's what we need to do next. Now we need to find slope at a certain moment. So let's say that my function was this. Let's say it was 2 sine x, and x is 3 pi, and I want to know the slope of this function at 3 pi. So they have a better way of saying it in the book. They say, okay, find the slope of the following equation at the value of x provided. This is what they mean. They mean they want you to find the slope at 3 pi, or estimate it. So what this question will ask, what this specific question asks, is it positive or negative slope?
Doesn't have to be positive.
So, positive or negative slope. This is all they want.
Does this have to be in radians?
So, yeah, so they're going to put it in radians because we have to draw it. So, we're not going to type anything in the calculator. You could type in some numbers close to 3 pi and put in radians on the calculator. I don't want to do that. I just need to know roughly what this thing is. So, by doing the simple graphs we've done the last couple weeks in here, we can draw this. Because sine, what's the period length of sine?
2 pi.
2 pi. Okay, so this is normally 2 pi. Its amplitude will be 2 and negative 2. Because I know that it's got the 2 up front, so, and then I can draw the sine graph. If I cut this in half, that's pi. Cut it in half again, this is pi over 2. Multiply by 3, this is 3 pi over 2. And I'm going to draw what sine would do. Okay? Okay, it looks something like that. That's the sine graph. Okay? I need to go up to 3 pi. So this will be 2.5 pi. Oh, I know that you're always adding pi over 2. So it's just half of a pi. And then I'll add it again. This is 3 pi. Okay, so by knowing that, if I keep continuing the hash marks, what will be my slope at that moment? Is it positive or negative? Negative slope. Because at this moment, right here, it is going down to the right. Correct?
And that's all you do on that?
Yeah, so on this particular problem, they want you to identify is it a positive or negative slope. It's negative slope, you move on to the next part. These are like the short, quick ones at the very end of the assignment. They ask you a series of questions to see if you're paying attention to the graph. So I had to draw one full period length of sine, and then I had to keep going and draw half more. Because you had to kind of figure out how that was going to work. It was eventually going to go up to 4 pi, so that's kind of how I knew it was going to be. But using this spacing, I knew that I could go 2 extra marks to get out to 3 pi. All right, questions with the sine function. Give me any trig function, by the way. I'm just picking sine.
Hopefully it's only sine.
Hopefully. Okay, now let's do another example. This is one I think I did on Tuesday a little bit. It's where they tell you that your function here, your function is odd symmetric. So your function is odd symmetric. The f prime of 2 is 7 over 10. They want to know f prime of negative 2. The weird part
Still
about
7 over 10.
Say it again?
Still 7 over 10, right?
Yes. Now, let's talk about it. Yes, you're correct. Now, okay, let's discuss why. Okay, he's right. It's 7 over 10. They didn't tell me the drawing. They didn't tell me. They just told me it's odd. So I could draw any odd graph. If you don't know what an odd symmetric graph looks like, the right and left side are kind of going the opposite directions. So maybe it will do something over here, like this, and the other side will go the complete opposite way. So instead of going up, it will go down instead. That's an odd symmetric graph. So he's right. If I went over to 2, and this slope is like 7 over 10, right? That's the slope right at 2. Well, if I went over to negative 2, what does the slope look like? It's the same. They're parallel lines. They should be. Because they're going the same direction. And he's absolutely right. That should be 7 over 10. You have to be able to like really quickly like see what an odd graph would look like, and then just roughly think about what slope would be at that moment. Would it be going the same direction? Would it go the opposite? What is it doing?
Is that because it's odd symmetric, they'd be the same?
Yeah. If it was even symmetric, they do the opposites of each other. So if one's going 2, it would go negative 2 on the other side. Because an even symmetric graph would look something like this. Right? Even symmetric, so let's say this is what the graph's doing. On the other side, it does the exact same look. So if this was 2, the slope's going that way. Negative 2, the slope's going in the opposite direction.
Would it,
It's negative.
would it say anything other than symmetric?
Nope. They wouldn't show you a graph or anything. They'll just ask you a series of questions. It's kind of like based on this one. They don't tell you anything. They're just like, is it even or odd? Or is it a positive slope or negative slope? They're just like quick hitters. They want you to see what to do. So they're supposed to be quick. I mean, sometimes you have to really kind of think about the ones that they're giving you sometimes. Okay, questions with those so far? Okay, now, there's two examples I want to talk about next. There's two. These are my last two today. So the last two examples. Okay, so last two. All right, so one of which will be, this is something we kind of did the other day. I'll just kind of, okay, all right. So let's say this is my function, it's just kind of some random drawing. They just give you a bunch of random drawings, and they'll ask you a series of questions about it. And what they want you to do is rank the following in order. Rank the following problems in order, in ascending order. Ascending order. So that means least to greatest. You're going up in power. So, or up in like terms of value. And they'll ask you for, f of 1 and f of 2 minus 1. Or find f of 5 minus f of 1 all over 5 minus 1, right? They're going to have you do a series of items, and they're going to have you see like what's going on there, okay? So I want to just kind of walk through the basics here. So these are my three options. I'll give you these three. I think they have them like bulleted, like 1, 2, 3 or something like that, or 4. There's like 4 of them. And they want you to put them in order by which one's the smallest, which one's the biggest, which one's the next biggest, that kind of thing, right? And you go in order, least to greatest. That's ascending. So f of 1. Well, f of 1, what is the value here at f of 1?
Whatever that number
What is that?
5.
Almost 5 something? It's almost 5. Not slope. They just want to know the value of it. It's like really close to the number 5. Agreed?
Yeah.
Like it's really close. That's f of 1. So f of 1 means you find 1 on the x-axis, you go find what the value is. It's the functional value. Right? Now, f of 2 minus 1. So f of 2 minus 1. So here's f of 2. Here's f of 1. So this is about what? 4.5. And so when I subtract these, what is that? About half-ish. It's about
So it's
half.
your difference?
So negative half, I would say. Yeah, it's the difference between f of 2 and f of 1. So that's about negative half. Now, why it's negative half? Because we had to put 2 in first. So f of 2, that's 4.5. F of 1 is about 5. So when you subtract, it's about negative half. And then f of 5 minus f of 1 all over 5 minus 1. Well, what does that mean? What does this thing stand for?
Slope.
It's slope. Slope at 5 and 1. Here's 5. So there's 1. There's the dot at 1. And
This is slope from the.
f of so that's f of 1. F of 5 is down over here. 1, 2, 3, 4, 5. Here's that one. What is that? 3. So this is 5 comma 3, and this is 1 comma 5.
So 3 minus 5.
All right. So there's that slope. So you'd have to estimate. Is it negative or positive slope?
Negative.
Negative. What does it look like it's dropping by? Well, you'd actually have to calculate it. So you'd actually have to look. It looks like it's going down. It looks like it's going down 1 over 2. So these are almost the same. It's almost negative half. So if you were putting them in order, I'd probably put these. It doesn't matter which one you think goes first. And then this one's obviously the biggest, so that one would have to be the last one, right? If you're going in ascending order. So it's really like quick hitters.
Wait, what'd you do at the bottom? I'm confused.
This one, it's the slope between these two dots. That's what it is. You had to recognize that this form that it's written in, f of 5 minus f of 1, it's the slope at that moment. So if I was putting these in order, like least to greatest, I'd probably think this is probably the least, this is probably the next, and then probably the next after that, maybe?
Yeah, but why f of 5 minus f1 is
Over-
negative 1/2?
Because you're dividing by 5 minus 1. This is the slope of that at that moment. So I'm looking at the coordinates, finding the slope between those moments.
So you can't just plug the numbers in?
You can plug the numbers in. I mean, you can plug in those values and find slope, and that's what it wants. It just wants slope at that moment between those two dots.
I was like, I'm not done. I did. What do you told me that? I probably
I'll come back.
This is the one out.
What?
Where's that
If
at?
you wouldn't have told us.
Okay, what are you lost on?
Tomorrow, I would have your email.
Oh, yeah, it's bottom order.
Oh, cute man.
I just don't know why you have it over 5 minus 1.
You're not plugging it in.
Yeah, just do that.
I got 1A.
1A, it's fine. If you get 1A, it's fine. That's
Is
Um,
there like a
did
set
you-
answer for that? Or
Did you actually subtract right? You subtracted the y numbers?
I
Or the...
put whatever we have there. Or I don't actually wait.
That's
I
3
don't know,
minus
I did it
5,
wrong,
which is
didn't I?
2 over
I was
4.
looking at- I don't know.
Negative 2 over 4.
Should be 2 over 4 negative, so it's negative 5.
Read a
So.
piece of paper.
Okay. All right, Isaac, what was the question you had? Sorry, I thought you asked something.
Okay, if you didn't even have the 5 minus 1 on the bottom, would the slope be negative 1 over 2?
Oh, it was a.
Oh, no, if the 5 minus 1 wasn't on the bottom, then you'd just be finding the difference in height. So f of 5 minus f of 1 would be the difference in height between 5 and 1. That's a difference.
Which would be
That's
2.
like 2.
But since it's over that, it means slope.
It means slope, yeah.
Oh, okay, that makes sense.
Yeah. So. Okay. All right.
It's still equal to negative half.
Yeah,
Or
even
is
if
that
you
just
plugged
a
it in.
coincidence?
It was just a coincidence. I just made a problem with it.
Oh, really?
Really, Mr. Ward?
I could have picked a difference.
Ward's a genius.
Didn't even mean to.
Genius.
I thought it was gonna be 0.
Okay,
Ward's a
yeah.
genius.
All right. All right. Let's move on. Last problem of the day. Last one.
Not good.
Did they say Ward's a savant?
No,
No.
because I'm not.
No.
I can't add in my head. I'm not smart. Far from it.
But
Not even close to the genius levels of them. So, all right. Okay. I'm far from a genius. Far from it.
you're a genius.
A math
So-
genius. Can we call you math genius?
You can call me an idiot, Savant. All right. So, all right. Okay. All right. Anyway, the last type of problem they're going to have you do, they're gonna give you a function. I'll just kind of make up something here. 7 to the x plus 2. They're going to give you a bunch of x numbers,
You plug them in.
and they're going to have you do a bunch of numbers, and then they're going to have you make a table with these x values. So you plug in 1, plug in 2, plug in 3, plug in 4. Just write down what these numbers are in your calculator, you know, whatever it is when you plug those into your x's. Once you have your table, then they're going to have you, so that's part A, find the table. Part 2, they say find the slope between any 2 moments. Maybe they say, so that's part 1. It's part A, find the table. Part 2, part B. Part B, they might say find the slope between 4 and 1. Okay, so then you're going to have to find normal slope. So that means you got to take your functional value for this, whatever this number was, whatever the functional value for for the 1 was, subtract these, those go on the top, your y numbers go on the top, whatever those numbers are, and then you're going to divide by the 4 and the 1, subtracted, right? Because you have to subtract the x numbers. So they might have you find slope. They might say find the slope as you get closer and closer to 3. So if you're going to get closer and closer to 3, plug in numbers that are really close to 3 and find the slope there. So if they don't tell you specific numbers, plug in like 3.1 and 2.9. Plug in numbers really close to 3 and find the slope right there. So they're going to have you just do very simple calculations of slope. This section is getting you used to just finding slope, knowing what a tangent line means. It means slope at a certain moment. You know, graphing, seeing what the graphs look like, seeing how to order things. So that's what our next assignment will be tomorrow.
Sounds good. Have a good day.
Okay, videos are online. I made sure that they're all there. I kind of updated it, made sure I went through, checked that the videos are working. They all are there. Tomorrow we'll have an in-class assignment. It'll probably due next week. I won't make it due before the end of class. It'll be too difficult to do. But it'll be due next week. I'm going to grade a bunch of papers tonight, so you'll see probably your grades being updated and whatnot.
Wondering,
So.
is 1 over 7 and 8?
Yeah.
Is that what it is?
That's what I got.
Oh,
So we're
okay,
getting more
that's
tomorrow?
it. Tomorrow.
Don't think it's that close to the 4th.